All right. So we're going to start on 9.4, which is solving a logarithmic function. So like I said, so today is when we are actually going to put together all the logarithmic properties we learned in the other two sections, and that will help us to solve it. So if we can all go to page 14 on your notes, I'll go ahead and start writing this. So I'll write a couple of things down, like always. I'll write it down, and then we'll talk about it when we'll use whatever I'm writing down and we're actually solving. So whenever you have an u equals to v, it basically means log of u equals to log of v. It may seem pretty intuitive, but it's better to put it down. It may seem pretty intuitive, but it's better to put it down. The reason why you're able to do this is because it's not true for every kind of function. Most of the functions, not most, all functions which are one-to-one. One-to-one, we know what that means. We did that in one-to-one. Basically means it passes vertical line test as well as the horizontal line test. So the inverse and the function, both of them are functions. So if it's a function, then you will have, it's one-to-one, and log u will be equal to log v. And also for exponent. So if u equals to b, any base raised to the power of u equals any base, same base raised to the power of e. Again, we know this, right? So we've done this again and again. 3 to the power of a equals 3 to the power of 2. That's how I said a equals to 2. If the bases are the same, the exponents will also be the same. We have seen this. And this is the reverse of that. If log base is of u equals the same, as long as the base is the same of another input, both the inputs will be equal to each other. Okay. So we're going to go into how to solve. There's some strategies that are depending on what's given to you. There's not one hard and fast rule. It totally depends on what's given to you. So it's just like solving a quadratic equation. You can't say I can always factor. It could be of the form of difference of square or whatever. So depending on what's given to you, you will solve in different ways. If the problem has log on only one side, like in this case, like 1a, it has log only on one side. What do? You rewrite as an exponential function. So this is where the things that we have learned comes into play, because you have to rewrite it as an exponential and solve it. But sometimes what happens is, yes, you will have log on only one side, but you might have multiple log terms. Like for example, e. There's log only on one side, right? There's the left hand side and the right hand side. There's log only on the left hand side. But what's happening here is there are two log functions. So you want to combine them. So sometimes before you rewrite it, sometimes you will condense. So I'm just going to write this down so it will help you to remember. Sometimes you will condense. Condense always means into one log term on the same side. If the problem has log on both the sides, this is one side, has problem on both the sides, then you will exponentiate both the sides. That means basically you will take the exponent of the log. So two kinds. One is if you have log on one side, one is if you have log on both the sides. And the last thing is check for extraneous solution, because it is not possible to find a log of a negative number. And I'll quickly tell you why. The reason you can't have a log of a negative number is, okay, when you go ahead and I'll quickly go ahead and draw a rough sketch of the parent log. Remember, logs have vertical asymptote. Okay, so we can't forget that the quiz also has graphing, because 9.1. So it has vertical asymptote, and then the way the graph works is it hugs the vertical asymptote, goes to the x-intercept, and slowly grows. Would you notice that all my x values are all after x, because I have are on this side of the x-axis. So it's only positive x values. So that is why it is not possible to find the log of a negative number. And you'll see that when we do the problems, a lot of these things will start making sense when we actually start solving it. What we mean by that. Okay, can I start? Anybody needs? Alright, so let's look at this. So solve this. So this is what they're telling us to solve. Solve. Basically we're solving for x. Okay, so you want to be thinking about is log on one side or both sides. So because those are the two strategies. If it's on one side, you want to rewrite it as an exponential function. Sometimes you will have to condense, but there's no condensing. There's only one term. So can we all rewrite this in the exponential term? So what's the base here? If it just says log, what's the base? 10. Perfect. Excellent. 10 to the power of 1. Excellent. Good answers. And x plus 1 is my input. That becomes the output. Therefore, easy, right? That's it. 10 minus 1, 9. But before I box it, you always want to check. Take this 9 and then you want to check. Check here. Log of 9 plus 1 is 10. It is positive, so now you can box it. Okay, we're going to do everything on this page. Okay, you guys do B. Same thing, there's log only on one side, there's no condensing because there's only one log term. Please rewrite it. And check before you finally box it. Okay, I'll be glad to show the work. I'm just putting it up for those who get done and they can check if they got it or not. But I will put up the work in 30 seconds. Let's do C. Another, again, very similar. A, B, C are all, but it's good to do few of these simple ones. Then D, E, F, we start combining. Does everybody understand check? What am I doing in check? I'm taking this, the value of x equals to 35, putting it here. Log of 6, 35 plus 1 is 36. All I'm checking is if the input for log is positive. That's all I need to know. I'm not doing anything else. That's all you're checking. Check it is not possible for log to have a negative in number. That's all I'm checking. That's what I did here too. 10,000 minus 2 is 10,000. So that's a positive number. So that's all I'm checking. Okay, can I go to D? Okay, so there is log only on one side, but I need to condense it. I need to condense it so that right now I cannot rewrite it in the exponential form unless I condense it. So Can we all do that? We did condensing in the previous lesson. We've done it as homework too. So let's all condense this as into one log term. So both have the same base. That's your first check. So ln of what? Is everybody good with this? This thing gets condensed into this. Two terms get condensed into one because it's a subtraction which converts to division. Okay, your answer will contain E. Don't try to replace. It's like having a pi in the answer. We tell you not to replace pi with 3.14. So your answer will contain an E because the E is a base here. Leave the E as is. Leave the E as is. I want you ahead of me. I will do the work, but I need you ahead of me. Yeah. Remember, ln has a base of E. What are we trying to solve for here? Trying to solve for x. That's my variable. So your goal, now you're using your algebraic skills. Your goal is to get x by itself. Now you're using algebraic skills. Keep in mind E is not a variable. So you can have E as a part of your solution. So you keep x on one side, everything on the other side, including E. Okay, what do you guys think? Yeah. Page 14. Yeah. What do you guys think about the solution? Yeah, everybody got so far? Okay, everybody understood that E square can be taken out, square root of E square, but 3 needs to remain under the radical. We all got this part also. So this is all algebra. Just, things that you know, but just need to be reminded, because sometimes you forget to do these things. Now, do both the values work? One of them is positive, one of them is just positive, which is e to the e square root of 3. So you substitute it here. It'll still be positive, right? This is the input for ln. That's where you're substituting. E square root of 3, everything is positive here, you put it here, it still says positive. Will the negative value work? Actually, it will, in this case. Can someone tell me why? Because the input for log is, it's not x, it is x squared. What happens to negative when you square it? It becomes positive. So both of them do work. If you want to write a small note, negative squared is positive, and that's why it works. Please do that. And then I want you guys to do E and and f. We'll do all of it on this page. Like I said, it's good to get the. Actually, we won't do x. I'm sorry. I'm not sure it's a great problem. Let's not do f. Let's just do e. Okay, sorry. Yeah, here's all the work. So I've taken the work to this side too. Yeah, it'll be okay. Yeah. Yeah, sure. Absolutely. So, let me number the steps. It'll be easy for us to talk. Was step number 1 clear? Yeah, okay. And then step number 2 is, this is where I convert to exponential. 2 is my base. So, 2 cubed became, this is my output. Sorry, this is my input becomes my output. Okay, so this is what. So, 2 cubed equals 3x plus 2 over x. So clear? Okay. Now what I do is, my goal is to get the x, but then what's happening is it's a part of a fraction. And I can cross multiply. So I basically do 2 cubed times x, which is 8. 2 cubed is 8. So 2 cubed times x, which is 8x, equals 3x plus 2 times 1, which is 3x plus 2. Yeah? Okay, good questions? Alright, can I go to the next page? Okay, so we're pretty much going to do a lot of these. it's just same. Okay, so it's going to be different. So now we're actually getting, I'm sorry, I don't know why I said that. It is going to be different. Now we're getting into a situation where we have logs on both sides. We have logs on both sides. Do you guys see that? So that's what we're going to, so there are two kinds, right? If it has log on one side, which is what we saw on the previous page. If the problem has log on both the sides, you will basically take the exponent on both the sides. So we do see there's log on both the sides. But before I can take the exponent on both the sides, you basically want to make sure that it doesn't have a coefficient. So I'm going to move this over to this. So it's basically going to be log base 5 of x square equals log base 5 of 9. X square is the input. So you will take the exponents on both the sides, but I'm going to kind of cut some of the steps. And what I'm going to be writing is basically coming from the fact that you're taking the exponent. Taking the exponent on both the sides. So when you take the exponent on both the sides, it basically what it comes down to is x square will be equal to 9, and that is pretty obvious, right? Because this is basically we're using this property. If log of u equals to log of v, u has to be equal to v as long as the bases are the same, correct? You guys wrote this down, and this is pretty kind of self-explanatory, and that's exactly what this is. Log base of 5 of x square equals log base of 5 of 9, which basically means x square equals to 9. Because my log functions are 1 to 1. The long way of solving this is, which will basically come to this, if I take exponent on both the sides, it will basically come to the same thing. If x square equals to 9, what's my x? Plus or minus 3? Okay. Now let's substitute the negative 3. Definitely positive 3 will work. You have to substitute in the original equation, not after you move the 2. You have to substitute in the original equation. When you substitute in the original equation, negative 3 does not work. So my final answer is x equals to 3. This has x equals negative 3. If you want to write this down so that you remember to check, is extraneous. Yeah.
A bit unrelated, but the unit 9T on Synergy has the unit 8 stuff.
Or is it unit 8 because the units have been moved? We split some of the units to make it easier to teach.
But the key doesn't match.
Oh, the key doesn't match?
No.
Okay, I'll look into it.
Okay,
Okay, so I'll look into it. So forget the unit numbers, just look at the content. And forget the first, so the initial part will say unit 8 preview. We did not do preview. We straight went, so look at from lesson 1, don't look at the preview. We did not do the preview. So just move over to lesson 1. It should start with graphing.
Yeah, the regular notes are fine, but like for me the key is the same.
Okay, I'll look into it, yeah. Okay, can we all try H? Again, there are two so this one is which one? Okay, so you have to kind of pause and make sure that what kind are we looking at. This has log only on one side. So this you convert to an exponential equation. But before you do that, you combine, right? So have we kind of start getting the hang of it? Okay, so look at it, pause hit pause on your brain and look at it and decide what can I do to this. So you look at it and you see, okay, there's log only on one side, that means I can exponentiate it. No, I'm sorry. I can basically take exponent on one side, but there are two log terms which can be combined to one log term. So combine it as one log term and then convert it to an exponential function. And I'll follow in a minute. Dominic, it's okay. So scroll the first 2 pages, go to page 3.
Okay.
Yeah, and then you'll find that it's the same. Yeah, you see it. Yeah,
You know, yeah.
yeah. This it's confusing because the first 2 pages had preview.
Yeah.
Yeah. So that's confusing because we didn't do it. You're right. Yeah. Oh, frozen. Yes. Thank you. So I'm not. Yeah, done. Not done. So this is just till where I've converted into a trinomial. So you have to factor this then. This is slightly larger numbers for factoring without calculator. But anyway, I just want to hit pause here to make sure we're all doing okay till this step. Please ask me if any of the steps is not clear.
Why are we multiplying them rather than dividing them?
Okay, good question, because it's a plus.
Oh.
Remember, plus converts to, yeah. So, Annalisa, I know you're not there for the last class, but basically it comes from this. So when you have exponents, like x to the 5th power multiplied by x square, you add these, right? You do 5 plus 2, and this becomes 7. So basically multiplication converts to addition. And then if you have division, x5 over x2, you do x cube. So division converts to subtraction. So it's the same concept. When you have addition, it converts to multiplication, and yeah. So it's coming from there basically, yeah. So can we all try to factor? Okay, first of all, are we all okay with the 4 steps that I put down? Yes, Tony.
The sun has x on there as 1, and then we moved it over.
Right, so basically from step 1 to step 2? You're asking from step 1 to step 2?
Yeah.
Yeah, so basically this is a log function and there's log only on one side. So I can convert this into an exponential function. How do you convert that? You take the base. Whenever you convert, the first thing you do is to take the base. The base is 10. Bless you. Yes, okay. The base is 10. And 1 is the output, becomes the input. And then this becomes the output because this is the input. Yeah? And then now it's just algebra. You're just multiplying, binomial multiplication gives me this, and then write it in the standard.
So is it only 10, like when you put it on, like when you move it?
Oh, why is this 10? Okay, so that's a good question. So this is whenever you see a log with no base at the bottom, you assume it's 10.
Yeah.
That's the default. I was trying to find the right
okay.
one. That's it. Just like when you have square root, when you have a radical symbol, and there's not, you assume it's 2, right? You always assume it's square root. Unless it's cube root or 4th root, if you don't give a number, it's square root. Same thing here. If log does not have a base, that means it's 10.
Okay.
That's the default, yeah.
Thank you.
Sure. So please go ahead and factor this. Okay, so quickly, you're going to, this is the where you factor, where you do 3 times negative 24, 3 times negative 24 is negative 72. Okay, so factors of negative 72 that add up to positive 1. 9 and negative 8 work. Okay, so just to help you along. So go ahead and put 9 and negative 8, do your grouping, do all, I want you guys to do it because factoring is always needed. So go ahead and give me the 2 factors.